Everybody, it's still November. Don't forget. All right. So today we're going to write systems of equations, but not from graphs. Today we're going to talk about it from tables. Now this is going to be a throwback to stuff we did mid-October, but I'll remind you how to do it. Make sure you turn in these assignments, the formative, the graphing linear systems from 11.8, and yesterday's writing systems of equations from graphs looks like this from the 11th. That's yesterday, right? Now, our warm-up today is just like yesterday's. You got to be able to take a standard form and convert it to slope-intercept form, or basically solve for y. How do we do it? Here's a reminder if you didn't already do it, but you always want to try these on your own. First step, to get y by itself, you got to get rid of this x. What's the opposite of minus 2x? Plus 2x? Plus 2x? Please remember, 9 plus 2x is not 11. It's not 11x, right? So again, 9 and 2x do not combine because they're not like terms. The plus 2x is going to go in front of the 9. So always put it in order. Bring down the plus 3y means it's a positive 3y. That's going to equal the 2x first, and the positive or plus 9 goes second. So again, opposite x in the right order. Then, how do I get rid of that 3 in front of y? We divide everything by that number, which is 3. So, y equals 2 over 3x, doesn't reduce. 9 divided by 3 is 3, okay? Now, quick notes, just one-sided. It's going to be a lot of review of what we did mid-October. But you got to be able to take two tables, find their equations, and find the solution. So it's kind of last month meets this month. All right. Here we go. Notes. Writing systems of equations. Now, here's our steps when we're doing this. We got to find the slope and the y-intercept from the table, okay? Then we got to write the first equation and then the second equation from the tables, and I will add, then you're going to find the solution. Now, if you don't already have a Chromebook, you don't necessarily need it now because I'm going to show you on the board, but you will need it when you do the assignment. I'm going to show you what to press, and this is the notes right here, okay? Step 1 is you're going to do a linear regression. Again, we did this 10-15. Okay, now all you got to do is add a table, and notice it says you're going to put just 2 points. If you know it's linear, you can use 2 points, okay? And then you're going to type below it y1 squiggle mx1 plus b. Hopefully that looks familiar from last month. And remember that little squiggle, it's not an equal sign. The squiggle is on the top left in your keyboard, shift. It's called a tilde, but I call it a squiggle. Okay, step 2, once you've done that, it'll tell you what's m and what's b. That's great. You can write it. Now here's the deal. This is kind of important. I'm going to show you this, but if you don't delete everything, if you just refill in the table, you don't have to type the y1 squiggle mx1 plus b again. I'll show you. But you basically do this again for the second table, and now you have 2 equations. And once you have 2 equations, can't you find the solution by graphing them and clicking where they intersect? Yes, you can. So I'm going to show you right now how to do this. One sec. Okay, so let's look at this first example. All right, so here's what I do. When you open Desmos from the launch pad, that way it's this, specific version, you hit the plus sign right here, right, where it says add an item, and you click table. Now, here's the trick. If it's linear, if you know it's linear, then you only have to use 2 points. So I know it's kind of weird that this table is sideways, but I'm only going to use the boxed information, 2 points. And remember, each row is going to match each column. First row matches first column. So this first row of x, negative 16, negative 7, I'm going to type it right here. And then the second row, negative 7, negative 4.75. All right, so I put in 2 points into my table since it's linear. I go down to this second place right here, and I'm going to type in, like we talked about, y1 squiggle m x1 plus b. So let's do that. Y1 squiggle m x1 plus b. So if you have to memorize that, y1 squiggle m x1 plus b. If you do that, it'll give you m and b right here. So m is 0.25, b is negative 3. So let's write that down for the first one. 0.25, negative 3. Now, remember, 0.25, I would like for that to be a rise over run slope. So remember, if you just type in any number and you click the circle that looks like a fraction, square over square, it'll make it turn into a fraction. So really, 0.25 is 1 over 4. 1 over 4. Now here's the dealio. If you write it as a decimal, it's not wrong, but you're mostly going to see it as a fraction. Okay. Make sure you're looking up here, not messing around on the Chromebook. So let's write this down. The equation is y equals 1 over 4 is my m, x plus b, which is minus 3. So just minus 3. 1 over 4x minus 3. So again, if you have a decimal slope, you can rewrite it as a fraction. 0.25 equals 1 over 4. Okay, now for my second table, once again, you're going to use these points. Okay? Now, watch me do this. Don't delete this. I'm going to go up to this table. I'm just going to delete the table values, not the whole table. All right. Now you see I have a blank table and I still have the y1 squiggle mx1 plus b, right? Just fill in that table with the new stuff. The first row, 17.9, is going to be my first column, 17.9. My second row, negative 18.25, negative 8.25, is going to be my second column. 79, negative 18.25, negative 8.25. All right, so I do that, and I look at my y1 squiggle mx1 plus b, and it has an m of negative 1.25 and a b of 3. Can't I type negative 1.25 and click this fraction circle to turn it into a fraction, right? So negative 1.25 is negative 5 over 4. My b value is 3. So y equals negative 5 over 4x plus, since it's a positive, plus 3. Okay, so this is just old news, stuff we've done before. You're doing it twice. But so what? I get equations. I need a solution. I need to take these equations and find the solution. And do you remember from the last couple of days, the solution is where they intersect, where they meet. Now look, currently on this screen, I have the second table graphed already. So if I can just graph the first equation, I can see where they cross. Down here, I'm going to type that first equation, y equals 1/4 x minus 3. Y equals 1/4 x minus 3. I think I may have said that wrong. So I have the second one already graphed. I just graphed the first one. Now I can see the black and the green line touch right here. What's that point? 4, -2 is my solution. Parentheses 4, comma, -2. I had two pieces of data, two tables. I turned them into two equations. I turned that into two graphs on Desmos, and I see where they touch. Intersection point is the solution. Okay? So I think you get it. Okay? But there's one little weird thing about number 2. I want to make sure I show you. So let's do another one, and then I'm going to let you work. On number 2, here we go. Now, I am going to delete, I'm not going to delete the table. I'm just going to, once again, delete the values. Okay, now, once again, it's linear, so I'm going to just put the first 2 points. So 3, 3, -9, 1. I don't know if y'all noticed this. Do you see the whole left side of this table is 3? Like all the x values are the same? Interesting. So whenever all the values are the same on one side, it's going to be a special type of line. We'll see right here. So I graphed these 2 points. Now, see these green points? By the way, let me get rid of this. You see this green point and this green point? Like this black line doesn't go through those 2 points, so like it's not a good line. But this point and this point are up and down. They're vertical, right? Like they should make a straight up and down line. So I want you to notice. Look at r squared and r. Do you see how it says undefined? We've talked about this, but when you're unable to stand on a line, like a vertical line, it's called undefined. Unable to stand, undefined. Okay? So when all the x values are matching, that's a vertical line. You cannot use what they give you on Desmos. Does everyone hear me say this? This is the one time Desmos will not give you the right answer. It's when it's the same x value, when it's vertical, when it's undefined. So for m, we're going to put undefined. If it's straight up and down, slope cannot be defined. It's not 0. That would be horizontal. Okay, the r equals undefined, so the slope is undefined. This is a very specific special case, so I hope everyone's hearing me say this. You got to notice when r is undefined, that's a vertical line. And if it's a vertical line, it doesn't cross the y-axis. If it never crosses y, there is no b value, none. So I'm telling you, when all the x's are the same, when it's undefined slope, when it's vertical, it has to be x equals the x value. So what does x equal? What is every x value here? 3. Okay? This is a special case when it's vertical, undefined, same x values. You have to write x equals a number. Okay, I've said it a couple times. That's it. Now, the other table, we should be able to get a good line out of. So let's go ahead and do that. Let's just, again, erase the values. If you want to retype everything every time, that's fine. But you got to remember that initially you have to type it correctly. Y1 squiggle M x1 plus b. That's not on a formula chart. You have to memorize it. So I always say it over and over. Y1 squiggle M x1 plus b. Okay, now let's do this. The first 2 points here, so 18 and 12, 27, 17. Now I've got a nice line, and it tells me that my slope is 1.6667. And then my b value is -3. But again, 1.6, that's a repeating 6. Y'all see that? It keeps going. So here's how you can do this. If you type 1.666, I know there's a fraction bar there, but you got to like keep typing it till it goes away and keep typing it till it comes back. That's a lot of 6s. But if it's 1 point, lots of 6s, you click the fraction bar, and now it'll give you the right fraction, 5/3. Okay? So 1.6 repeating is 5 over 3. That's the most accurate fraction. So y equals mx plus b, 5 over 3x minus 3. Cool. Now, this second equation, 5 over 3x minus 3, is already graphed in black here. So now I'm going to just type in the first equation, which we said is x equals 3, the vertical line that's undefined slope. X equals 3. And now I can see that I have two lines that are touching right here at 3, 2. Again, there it is on the graph. You can see it. Most of the time, you're going to get a slope and a y-intercept. Sometimes you'll need to figure out the slope as a fraction, and very rarely, but sometimes, if it's a vertical line, undefined slope, all the x's are the same, you write it as x equals a number. Okay, so I know I've been a broken record here. This is how you're going to do your assignment. I need you to finish yesterday's assignment, work on this one for today, because it might be on tomorrow's quiz, right? So you got to know this stuff. Make sure you get some practice. Let y'all work. Here we go.